So you've started your journey into observability by implementing OpenTelemetry. All your microservices has been successfully instrumented and they are producing telemetry data to the observability backend as clockwork. Life is great. Everything just works. But then one day, the decision has been made to change the currently observability backend to another, and it is your job to make that happen. And then you start panicking. Am I going to lose all the instrumentation that I have worked so hard to implement? Do I have to actually change the code to make that happen? In this video, I'm going to answer all these questions. Hello there and welcome. My name is Ricardo Freire and I'm a developer advocate here with AWS. Before we move forward, let me take this moment to say congratulations. You might not realize that at this point, but if you followed all this series until the end, it means that you were able to accomplish something that not very people can do, which is implement an end-to-end scenario using OpenTelemetry. That's huge. So take this time to actually realize, yeah, did I do this? Yes, you did, and you were awesome. But it doesn't mean that our conversation has to stop right there. In this video, I'm actually going to discuss something that's considered one of the most important characteristics of OpenTelemetry, which is its ability to provide you a vendor-neutral implementation for observability. What that means? It means that you can start your observability implementation with one observability backend, do all the instrumentation process and make everything happen, and then in the future, you can actually switch to another observability vendor without necessarily losing all your instrumentation code. And as we have been discussing all this time, talk is cheap. Let's see how this works in practice. In this example, I'm going to show you how can we switch the observability backend that we have been using throughout all the series to AWS. So in case of traces, we're going to change from Grafana Temple to AWS X-Ray. In case of metrics, we're going to switch from Prometheus to Amazon CloudWatch. However, I think it's important for us to kind of catch up in everything that we have done so far so we can understand what is going to happen on AWS. So right now we've been using the collector, the OpenTelemetry collector, to actually transmit all the produced telemetry data to the observability backend. So as you can see here, we've defined two exporters, one for Prometheus and another for OTLP, which is the protocol for OpenTelemetry to actually communicate with Prometheus and Grafana Temple respectively. You can actually double check this by taking a look here on the service pipelines implementation. In the metrics, we're exporting all the metrics both to the login and for Prometheus. And for the traces, we're exporting to the log and to OTLP, which points exactly to this endpoint for Grafana Temple. Now, one important aspect that you have to realize before you do the switch with the promise that you are not going to change all your code is the usage of the best practice, which is the implementation of the OpenTelemetry collector. So, as you have realized at this point, the microservice that we're using for testing is sending all the generated telemetry data to the collector, and the collector is doing this job of transmitting to the observability backend. So, you might have heard me saying in previous videos from the series that you optionally can avoid using the OpenTelemetry collector, and if the observability backend supports protocols that are compatible to what you are doing in OpenTelemetry, OTLP for example, you could actually send directly from your code to the observability backend. Although this might be interesting for the sake of simplicity, I think this actually should be a seed that you should plant during your implementation to make this possible. So in other words, if you didn't use the OpenTelemetry collector, you would have to go back to your code and change all the endpoints and exporters that you have used and configured there. All right. Sometimes this is possible, sometimes it isn't, but the best practice is to use the OpenTelemetry collector to create this layer of interaction between your source code that produces telemetry data to your observability backend. So what we're going to do right now is to actually create another collector configuration that is going to use specific exporters that's going to communicate with AWS X-Ray and Amazon CloudWatch respectively. Before we move forward, make sure that whatever containers for the current observability backend, if they're running, you have to stop them right now. So to make that sure, I'm going to open a terminal here and shut down all the container if they are running. If not, that's fine. So all of them has been removed and they're not running at this point. So what I'm going to do now is to create a new configuration file. So currently we have one called collector config local because we've been using a local observability backend. So I'm going to create another one, which is going to be called collector config, and I'm going to call AWS, and it's going to be a YAML file. So in this file, I'm going to actually create this configuration that, as you can see here, it looks like what we have done before. So in terms of receivers, we're going to continue to receive all the telemetry data over the protocol OTLP through an endpoint that's going to be available over the port 5555. So that is important because currently our microservice is configured and implemented to send the telemetry data to that endpoint. So we're creating another version of the same endpoint. So for the sake of the microservice, it didn't gonna know what the chain was made. And then we're going to define different exporters. So one of them is going to be called AWS EMF. So this is the exporters that we're going to use to transmit all the metrics to Amazon CloudWatch. And as you can see here, you were required to specify the region where you were going to send the telemetry data, right? And the actual log group name and stream name where all the raw data for those metrics are going to be stored on that region. Also, we've defined another exporter called AWS X-Ray, and we're saying here that we're going to also use the region North Virginia to send all the traces generated. And more importantly, and hopefully you have like learning at this point, the definition of the exporters or the receivers doesn't matter much if you don't use them here on the service pipeline implementation. So for the metrics, we're receiving via OTLP and we're exporting to AWS EMF, which is Amazon CloudWatch. For traces, we're receiving via OTLP and we are exporting to AWS X-Ray. However, you might have noticed that we've included another component here called processors, and we're using this processor called batch that we've defined here. So what is this processor? This is something that you can put in between when you receive the telemetry data and when you are going to actually export it to the backend to perform some sort of like normalization, buffering, or make the data into a specific format that you needed. But in this case, we're using a batch processor, which basically, as the name implies, is going to batch all the data and is going to actually buffer them until they reach either this rule here of every 5 seconds is going to flush for the backend, or if it accumulates enough bytes, in this case 1024 bytes, is going to actually flush to the observability backend. This is not necessarily required for actually to use, but this is another best practices that you can use to sometimes not overload your observability backend. This is particularly important if you are using AWS cloud services, because if you, during your development and testing purposes, you are going to perhaps overload all a specific region and the view might come due. So I want to make sure that during this testing, you don't overload and ended up with a view that's going to be so high. So that's why we have this kind of a step of making sure everybody understand what's going to happen before they start the implementation of it. So now that we have created this configuration file, so as you can see now we have 2 configuration files. So as of now, we can spin up a new collector using any one of these configuration files. So that's one of the beauties and the flexibility of the OpenTelemetry collector. You can spin up one instance pointing to a specific configuration and another instance to another configuration. So to make things a bit more interesting, we're also going to create another Docker file to keep things separated. So one Docker file, which is this Docker compose file over here, spin ups our current collector that's going to point to our local observability backend along with the observability backend itself, which is Grafana Temple and Prometheus and the Grafana visualization tool. So in order to keep things separated, I'm going to create another file called Docker Compose AWS YAML. And in this file, I'm actually going to define only the collector. So you might be wondering, Ricardo, why you are not defining the observability backend? Because the observability backend at this point is going to be AWS. So the whole backend is going to be running on the cloud. So I don't actually need to define anything here. All the definition that is required is from the configuration of the collector that's going to point to AWS. So as you can see here, I'm using a same name for the collector, but I'm using a different image here. So if you compare to the Docker Compose file that we've used before, you're going to see that in this version of the collector, we're using the default distribution from the OpenTelemetry project. Whereas in this new version of the Docker Compose file, we're using this image that comes from AWS Observability. So what that means actually, it just means that we're using a different distribution that contains external support for something that is unique to AWS, such as, for example, in the configuration file that you have seen before, those exporters, AWS EMFs to transmit data to Amazon CloudWatch or AWS X-Ray, are only available on AWS's distribution of the collector. However, the important part here is that this distribution from the AWS has been created from the base code of the OpenTelemetry collector distribution. So, in other words, we'll still provide compatibility with that collector, but we've included some add-ons to make the builder's life more easier. So you can rest assured that this implementation here won't break any compatibility problems with your OpenTelemetry implementation. And then there are some interesting things to uncover here. So the first one is that, as you can see, we're actually providing the configuration file here that we've created. So the collector config AWS, we're binding to the internal configuration file that the image of this container expects, just like we did with the other collector. But there's one thing that is important for you to understand. We're also binding the current file that I have here for my AWS credentials that I have configured on my machine using the command AWS configure. And we're binding to this kind of a file from the /hoot folder from the Docker image. So why this is important? So the Docker container is going to produce data to AWS. In order for this to happen, it needs to act as a consumer of the AWS endpoints. Therefore, it needs to have access to the AWS credentials that are going to allow that. Otherwise, the collector won't work because it won't have the means to actually invoke all the endpoints from the AWS. So what we are doing here is providing the same credentials that I have here on my machine to the Docker container image. This is one of the ways you could do this. Another way, this image also supports you to provide your credentials using environment variables. That's another way to do it. Or perhaps you can create a service account or a session token. There are different ways for you to provide the credentials that this container is going to need to invoke the AWS services. Now that we have configured everything, let me spin up this Docker container so we can thereafter execute our microservice, send a couple requests, and see if this data is being transmitted to AWS. To kick things off, I'm going to open up a new terminal so we can actually spin up the container for the OpenTelemetry collector. So for us to be able to execute that container, we have to actually provide the new configuration file for the Docker Compose that we've used before. So as you can see here, we're using Docker Compose and provide the different files for Docker Compose, AWS, and YAML. So when we execute this, we're going to actually spin up the new container collector instance that is using the proper configuration to send the data to AWS. So at this point, the collector should be up and running, and it is. So in this case, I'm going to simply re-execute our microservice that hasn't changed the code, neither for the script or the actual Java implementation. We're going to reuse the script as is, so we can actually send a couple requests to it, and then we're going to switch gears and go to the AWS console to see if the data ended up there. So the microservice is up and running, which is good. So let me send a couple requests to it. So curl -x get. So let me use the history here. So this is going to be the first request, and then we're going to send a second one. Now that we have done this, let's go to the AWS console to see if everything is working. At the AWS console, the first thing you have to verify is whether you are using the correct region that you have used it for the collector configuration file. So as you can see here, I'm using US East North Virginia, which points to US East 1, which is what we have used it in the configuration file. To visualize all the traces generated, here on CloudWatch, go to the section that says X-Ray traces and click on traces. So when you do this, you're going to be able to actually filter for a specific timeline when the traces were generated. And then as you can see here, in the last 5 minutes, we've created 2 traces because we have sent 2 invocations to the microservice. So you can actually visualize those traces by scrolling down to the bottom of the page, and we're going to see some kind of a high-level summary of each trace. And in this column called ID, you're going to see a link for that particular trace that was generated. If you click on that link, you're going to see not only this trace map, which is kind of a very cool representation of the interactions that happen between the client and the Hello App microservice, but in the bottom of this page, or if you can comprise the trace map, you're going to see the segments timeline, or just timeline as we call it. And you're going to be able to see all the root spans and the child spans that were generated. So as you can see here, not only this representation shows you the root span and spans created automatically by the OpenTelemetry agent for Java, but also the custom spans that we've created using manual instrumentation. Meaning that all the traces that you are seeing right now were the result of everything that we have implemented throughout the series. So you've literally reused all your distributed tracing implementation without changing the code, which is a good thing. So let's take a look now in the metrics that were created in this period. To visualize the metrics, go to the side menu here on Amazon CloudWatch, and then click on the option All Metrics, under Metrics. And here, you're going to be shown all the metrics that have been collected so far, not only from the microservice, from Hello App, but also for all the other services that you've used from AWS. You can filter for the specific metric that you want to showcase here, such as, for example, the number of executions metrics that we've created programmatically. So when you hit enter, you're going to be shown on that metric. So once you filter out, you can select it, and then you are going to be shown this graph here that is going to visualize the current value of that metric. So as you can see here, the current value is 2 because we have sent 2 invocations to the microservice, which means that this visualization is showing the correct number of executions that we have sent to the microservice. Pretty cool, huh? This is the proof that you have successfully switched from one observability backend to another without touching in a single line of code of the microservice. This is the beauty of OpenTelemetry. Instrument once and reuse everywhere. If you like this content, please hit the like button and don't forget to subscribe for more content like this. See you next time.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.